over hypothesis testing for one sample proportions. This is called a one sample z-test for proportions. So in our example, we have a researcher wants to investigate whether a new vaccination program is effective in reducing the incidence of a certain disease in a population. The researcher selects a random sample of 500 individuals from the population and finds that 80 of them have been vaccinated against the disease. The researcher wants to test the hypothesis, so here's our hypothesis, that the proportion, so we're talking about proportions, so whenever we have a proportion, we know we're using the proportion z-test. Then it says of vaccinated individuals in the population is greater than, so greater than 0.1. So we only have one sample here, and it's a proportion, so we're going to use a one sample z-test for proportions. So first, they are claiming that the population proportion is greater than 0.1. So that's the claim. So our null, remember, is always equal. So it's going to be our p is equal to 0.1. And then our alternative is going to be, this time it says greater than. So we're going to use the greater than. All right. So now we have our claim and our hypothesis written out. So now we need to check if we meet our requirements. So we have our n is 500, 500 times 0.1, this is our NP. So if you do the 500 times 0.1, we're going to get 50, and that is greater than 10, so we're good. The next one is going to be 500 times 1 minus that 0.1, so times 0.9. And that's going to give us 450, which also greater than 10, so we're good there. Next part, random samples. It says it was a random sample, so we're good there. And also 10% of the population size. We can assume that this was a large fraction of the population that they were looking at, so we're going to say that is greater than 10% or less than 10%. So the next part, since we've checked our 3 different conditions, is to run our test. So we're going to go over to our app, and we want to go into number of successes. Sample size we have is 500. Number of successes, it tells us that 80, so it finds that 80 of them have been vaccinated, so that would be our successes. And for this one, we want to do a significance test. So we see our p is 0.1, so we're going to put in 0.1. And this one, we have greater than, so we're going to put in greater than. Again, let's check if these line up. So p equals 0.1, p equals 0.1, p is greater than 0.1, p is greater than 0.1, so we are good. Our test statistic is 4.47, way out here. P-value is essentially 0. So let's go ahead and put those in. Our z equals 4.47, and then our p is 0.0000. Oh, sorry, let's put that down here. So 0.0000 is less than our 0.05. And if you don't have a level of significance, we're just going to assume it's 0.05. So that means we reject the null. P is less than alpha, so we reject the null because P is less than alpha. And when we reject a null, that means there is convincing evidence that the proportion, this part here, the proportion of vaccinated individuals is greater than 10% or 0.1. So in this case, we rejected the null, which means we have evidence for the alternative. You can see the alternative that the proportion is greater than 0.1. So there's convincing evidence that the proportion of the individuals, vaccinated individuals, is greater than the 0.1. So whenever we reject the null, we have evidence for the alternative. If we fail to reject the null, we do not have evidence for the alternative. And that is how you run a one sample z-test for proportions using the app.